Of course, this is an excellent goal. While the Basic Operations Certificate is less stringent than the Advanced Operations, aiming for the advanced knowledge will make you an exceptionally safe and prepared pilot, and it will make passing the basic test effortless. Here is a comprehensive guide covering everything you need to know, structured from pre-flight to post-flight, tailored for the Canadian context. First, you must understand which set of rules you're flying under. In Canada, it's based on risk. Basic operations, lower risk flights. You cannot fly over bystanders, anyone not associated with the flight, in controlled airspace, without permission, closer than 30 meters horizontally from bystanders. Advanced operations, higher risk flights, requires passing the advanced pilot exam and getting a flight review. This allows you to fly over bystanders, under specific conditions, in controlled airspace, with permission, within 30 meters of, but not over, bystanders. Since you're taking the basic test, you must know the limits of basic operations cold. You must know the difference between controlled and uncontrolled airspace. Controlled airspace exists around airports, heliports, and busy flight paths. Under basic operations, you cannot fly there without permission. Always check NAV Canada's drone site selection tool on the day of your flight. Avoid no-fly zones near airports, 5.6 kilometers radius, heliports, 1.9 kilometers, plus national parks, military bases, emergency operation sites, and protected areas. Assess conditions. Know your drone's max wind rating and beware gusts. Maintain VLOS and watch cloud ceiling and visibility. Avoid precipitation. Rain or snow can damage electronics. Check NOTAMs for temporary flight restrictions such as air shows, VIP movement, or rocket launches before you fly. If your drone is between 250 grams and 25 kilograms, it must be registered with Transport Canada, and the registration number must be clearly marked on the aircraft. You must have your basic pilot certificate with you when you fly. Perform a pre-flight inspection. Check for physical damage to arms and propellers. Verify battery health and cell voltages. Ensure propellers are secure. Confirm sensors and camera are clean and functional. And check SD card space and camera settings. Survey your launch area. Identify hazards like people, buildings, cars, power lines, trees, and water. Establish an emergency landing zone away from people. Plan your route, max altitude and distance. And consider who is around. Visual line of sight VLOS. This is non-negotiable. You must be able to see your drone with your own eyes without binoculars to maintain orientation and see and avoid other aircraft. First-person view, FPV goggles alone are not sufficient. Maximum altitude, 400 feet above ground level, AGL. If you're on a hill, it's 400 feet from where you're standing, not from sea level. Give way to manned aircraft, always. You are the bottom of the pecking order. Land immediately and safely if you see or hear a plane or helicopter. Do not fly recklessly. No flying too close to people, animals, or property that you endanger them or violate their privacy. Stay out of clouds. You must remain clear of cloud and not fly in fog. VLOS, visual line of sight. BVLOS, beyond visual line of sight, illegal without a special permit. FPV, first-person view, using a video feed, but you must still have a visual observer maintaining VLOS for advanced ops. AGL, above ground level. MSL, mean sea level, used in aviation maps, but your 400 feet limit is AGL. NOTAM, notice to airmen. Meter, aviation routine weather report. CTA, CTZ, control area, control zone, types of controlled airspace around airports. Dynamic pressure, the pressure on the drone from moving through the air, affected by speed and wind. Where can you find the most accurate information on airspace restrictions? NAV Canada's drone site selection tool. What is the maximum altitude you can fly your drone? 400 feet above ground level, AGL. You are flying in a park and hear a helicopter approaching. Land immediately and safely. What must you do before flying a drone between 250 G and 25 kilograms? Register it with Transport Canada and mark the number on the drone. Can you fly over a crowd of people under basic operations? No. What does VLOS mean? Maintaining visual line of sight with your drone. Look at this map. Based on the symbols, can you fly here? Who is responsible for ensuring a drone flight is safe? The remote pilot in command, that's you. Transport Canada's study guide. This is the Bible. Read it cover to cover multiple times. Transport Canada. Study and preparation guide for the drone pilot certificate. Take practice tests. Many online schools offer free practice questions that mimic the real test format. This is the best way to identify your weak areas. Use the tools. Go to the NAV Canada drone site selection tool and plug in your address. Learn to read the map and the airspace information it gives you. Review sample maps. Search for Canadian VFR navigation chart samples online to get familiar with airspace symbols. By studying this advanced level material, the basic test will feel like a review. Good luck. Fly safe and responsibly. Disclaimer: this guide is for informational purposes to help you prepare for the knowledge test. Always consult the official Transport Canada regulations and guidelines for authoritative legal information. Regulations can change. Of course, this is the core of the exam. Here is a detailed breakdown of Canadian air law, air traffic rules and procedures for drone pilots, focused on the rules you must know for the Basic Operations Certificate. 1. The legal framework, CARS Part 9. All drone rules in Canada are established under the Canadian Aviation Regulations, CARS Part 9, remotely piloted aircraft systems. Knowing this is the first step. 2. Pilot and drone certification requirements. Basic Operations Advanced Operations Pilot Certificate mandatory. You are getting this. Mandatory knowledge test, basic online exam in person, advanced exam flight review, not required, mandatory, with an accredited reviewer, drone registration. Mandatory, if 250 G, 25 kilograms. Mandatory, if 250 G, 25 kilograms. Drone marking registration hash must be on the drone. Registration hash must be on the drone safety assurance fly according to the rules below. Maintain a safety assurance. Your pilot certificate number must be provided to any law enforcement officer upon request. 3. Airspace classification and rules, the most critical topic. This is the most tested area. You must know where you can and cannot fly. A. The golden rule of basic operations. You are prohibited from flying in controlled airspace unless you have explicit permission, which, under basic rules, is very difficult to get. Therefore, for the basic exam, the answer is almost always, don't fly there. B. How to identify controlled airspace. Class C, D, E airspace. This is the airspace around airports and along airways. It is depicted on charts. Class F airspace. Advisory or restricted. If it's Class F restricted, you cannot enter. Control zones, CZ, control areas, CA. These are types of controlled airspace. C. The tool you must use. You are legally required to check airspace before every flight using the official NAV Canada Drone Site Selection Tool, or a tool that uses its data, like the Drone Pilot Canada app. This tool provides a yes/no/maybe answer for your planned location. Green. Yes. Uncontrolled airspace, Class G. You may fly here following the basic rules. Red. No. Controlled airspace, Class C, D, E, etc. You cannot fly here under basic operations. Yellow. Maybe. You need to review the specific restrictions, for example, near a heliport. For basic ops, treat this as a no. D. Key airspace distances. Memorize these distances. Airports, with a control tower, 5.6 nautical miles, approx. 9 kilometers, radius. Heliports, with a control tower, 1.9 nautical miles, approx. 3.5 kilometers, radius. Aerodromes, without a control tower. You must not interfere with aircraft operations. Keep well clear of runways and approach paths. 4. Flight rules and procedures, the do's and don'ts. These are the non-negotiable rules you must follow during flight. A. Altitude and distance limits. Maximum altitude, 400 feet above ground level, AGL. If you take off from a hill, your limit is 400 feet above that hill, not from sea level. Distance from bystanders. You must not fly closer than 30 meters horizontally from any bystander, any person not involved in the operation. B. Right of way. You must always give way to manned aircraft, planes, helicopters, gliders, etc. Land immediately and safely if one is approaching. You are the least important vehicle in the sky. C. Visual line of sight, VLOS. You must always keep your drone within unaided visual line of sight, no binoculars. You must be able to see its orientation, position, and to see and avoid obstacles and other aircraft. Using FPV goggles. You can use them, but you must have a second person, a visual observer, beside you maintaining VLOS with the naked eye and communicating with you. For basic ops, this is complex and often not practical. D. Operational limits. Never fly over or within 30 m of bystanders. Never fly in a reckless or negligent manner that endangers aviation safety or people. Never fly at night, sunset to sunrise. Never fly in clouds or fog. Never fly where it could interfere with police or first responders. Note, flight at night is technically possible under basic rules if the drone weighs under 1 kilogram and has lights allowing you to maintain VLOS. However, it is a high-risk operation and heavily tested. The safest answer for a new pilot is to avoid it. 5. Pre-flight procedures, your legal duty. Before each flight you must 1. Plan your flight using the Nav Canada tool. 2. Check for NOTAMs, notices to airmen for temporary flight restrictions. 3. Assess the weather, wind, visibility, precipitation. 4. Inspect your drone. Check for physical damage, battery levels, and secure propellers. 5. Ensure your registration and certificate are available if needed by authorities. 6. Sample exam-style questions on Air Law 1. What is the maximum allowable altitude for a drone? A. 500 feet AGL vertical bar. B. 400 feet MSL vertical bar. C. 400 feet AGL vertical bar. D. 200 feet AGL2. You want to fly 4 kilometers from a major international airport. Is this allowed under basic operations? A. Yes, vertical bar. B. No vertical bar. C. Only with a visual observer vertical bar. D. Only if I fly below the trees. 3. A helicopter appears near your operation. What should you do? A. Fly higher to see it better. Vertical bar. B. Move my drone 30 m to the side. Vertical bar. C. Land immediately and safely. Vertical bar. D. Ignore it, I was there first. 4. What is the minimum horizontal distance you must keep from a person not involved in your flight? A. 5 meters vertical bar. B. 15 meters vertical bar. C. 30 meters vertical bar. D. 50 meters 5. The Nav Canada drone tool shows your location as a red no. What does this mean? A. The weather is bad. Vertical bar. B. It is always night there. Vertical bar. C. You are in controlled airspace. Vertical bar. D. There are too many buildings. Key takeaway. For the basic exam, your mindset must be ultra-conservative. If there is any doubt about airspace, bystanders, or safety, the correct answer is always to not fly or to land immediately. Of course, meteorology is a critical subject for the drone pilot exam and for safe flight operations. You are responsible for understanding how weather conditions affect your drone and your ability to control it safely. Here is a comprehensive breakdown of the meteorology knowledge you need for the Canadian drone pilot exam. 1. Key weather concepts and definitions. You must understand these fundamental terms. Meter, aviation routine weather report, a coded observation of current weather conditions at an airport. You should know how to find and interpret key parts of it, for example, wind visibility. TAF, terminal aerodrome forecast, a coded forecast of expected weather conditions at an airport. NOTAM, notice to airmen, a notice containing information essential to personnel concerned with flight operations but not known far enough in advance to be publicized otherwise. For example, temporary airspace restrictions, rocket launches, air shows. Wind, the horizontal movement of air. It is reported as the direction the wind is coming from and its speed. For example, 27,015 kT is wind from 270 degrees at 15 knots. Gusts, a brief sudden increase in wind speed, reported as G in a METAR, for example, 20 G 30 kT. Gusts are particularly dangerous for drones. Wind shear, a sudden drastic change in wind speed and/or direction over a short distance, highly dangerous as it can cause rapid loss of control. Visibility, the greatest horizontal distance an object can be identified, critical for maintaining VLOS, reported in statute miles SM in North America. Ceiling, the height above ground level AGL of the lowest cloud layer that is reported as broken or overcast. This defines your maximum usable altitude. Precipitation, any form of water particles falling from the atmosphere, rain, drizzle, snow, hail, ice pellets. Most drones are not waterproof and can be severely damaged. 2. How weather affects your drone in flight. This is the practical knowledge the exam tests. A. Wind, the biggest hazard. Stability and control. High winds make the drone unstable, difficult to control precisely, and can cause it to drift significantly. Battery life. Fighting a headwind drastically reduces flight time and battery power. You will use significantly more battery returning to home against the wind than you did flying out with it. Gusts can cause sudden altitude loss or push the drone into an obstacle. Takeoff, landing. The most critical phases of flight. Always take off and land into the wind for better stability and control. Rule of thumb, if the wind is stronger than tilde 2/3 of your drone's maximum advertised wind speed, do not fly. For many consumer drones, sustained winds above 25 to 30 kilometers per h, 15 to 20 miles per hour, become very risky. B. Temperature battery performance. Lithium polymer, LiPo batteries hate the cold. Their ability to hold a charge plummets in low temperatures. Pre-flight, keep batteries warm, for example in an inside pocket, until you are ready to fly. In flight, a cold battery will show a sudden voltage drop, leading to an unexpected low power warning and forced landing. Always account for reduced flight time in cold weather. Density altitude, high temperatures and/or high altitudes mean the air is thinner, less dense. This reduces propeller efficiency, meaning the motors have to work harder to generate lift, which also reduces flight time. C. Visibility and clouds, VLOS. Requirement: by law, you must maintain visual line of sight. Fog, mist, haze, or low clouds can obscure your view of the drone, making the flight illegal and unsafe. Cloud clearance: you must stay clear of cloud. The basic operations rule is effectively, don't fly in or near cloud. For advanced ops, there are specific distances from cloud required. D. Precipitation loss, water damage. Drones have numerous vents and are not waterproof. Moisture can short-circuit electronics, damage motors, and obscure cameras and sensors. Icing: in temperatures near or below freezing, moisture can freeze on the propellers and body, adding weight, changing aerodynamics, and causing a crash. Do not fly in conditions where icing is possible. E. Pressure barometric altimeter. Your drone uses a barometric pressure sensor to hold its altitude. Rapidly changing pressure, for example in a fast-moving weather system, can cause the drone to drift up or down unexpectedly. 3. Weather resources and pre-flight planning. You are responsible for checking weather conditions before every flight. 1. Aviation weather websites. Use sources designed for aviation, not just a standard weather app. Environment Canada Aviation. Weather provides meters and TAFs. NAV Canada Aviation Weather website, the official source for pilots. 2. Decode a meter. You don't need to be an expert, but you should understand the basics of a meter string. Example: SWIAO 041300Z 27015. G22, KT15 SM, BKN 030, OVC 11204, A2992, CEAO, Ottawa Airport 041300Z, day 4th of the month, time 1300 UTC Zulu, 27015 G22 KT, wind from 270 degrees at 15 knots, gusting to 22 knots, 15 SM, visibility, 15 statute miles, BKN 030, broken clouds at 3,000 feet, AGL, OVC 100, overcast clouds at 10,000 feet, AGL 1204, temperature 12 degrees Celsius, dew point 4 degrees Celsius, a 2,992, altimeter setting, 29.92 INHG3, local observation. Always do your own weather check at the launch site. Look for flags, smoke, waves on water, and tree movement to judge wind speed and direction. Feel for rain or temperature. 4. Sample exam-style questions on meteorology. 1. What is the most significant effect of cold temperatures on your drone's operation? A. It makes the drone heavier vertical bar. B. It significantly reduces battery performance vertical bar. C. It makes the propellers brittle vertical bar. D. It attracts static electricity too. The meter reports wind as 24,010 G18 KT. What does this mean? A. Wind is variable vertical bar. B. Wind from 240 degrees at 10 knots, gusting to 18 knots vertical bar. C. Wind from 240 degrees at 18 knots vertical bar. D. Peak wind speed is 10 knots 3. Why is flying in fog dangerous? A. It wets the drone vertical bar. B. It is always below freezing vertical bar. C. It makes it impossible to maintain visual line of sight. VLOS, vertical bar. D. It attracts lightning 4. You are planning a flight and the forecast calls for 25 kilometers per h winds with gusts to 40 kilometers per h. What should you do? A. Fly anyway but stay low, vertical bar. B. Fly quickly to finish before the gusts come. Vertical bar. C. Postpone the flight due to dangerous wind conditions, vertical bar. D. Only fly downwind 5. What does a sudden significant drop in your drone's battery voltage during flight often indicate? A. The battery is new and needs cycling, vertical bar. B. The GPS signal is lost, vertical bar. C. The battery is too cold, vertical bar. D. You are flying too high. By understanding these meteorological principles, you will make smarter, safer decisions about whether or not to fly, ensuring you pass the exam and become a responsible pilot. Of course, this area covers the technical knowledge of the drone itself. For the Transport Canada exam, the focus is on practical knowledge that impacts safety and regulations, not deep engineering. Here is a breakdown of RPS airframes, power plants, and systems with definitions and what you need to know for the exam. RPS airframe definition: the physical structure of the drone, including the fuselage, arms, propellers, and landing gear. Key types: multi-rotor, quadcopter, hexacopter, octocopter, redundancy benefits, fixed wing, efficient long range needs runway, hybrid, VTOL, combines hover and efficient forward flight. Key pre-flight inspection points: check propellers for cracks or chips, inspect arms frame for stress fractures, ensure landing gear is secure and undamaged. Power plants, the system that provides thrust. For most small RPS, this is electric, batteries, brushless motors, and ESCs. Batteries are almost exclusively lithium polymer, LiPo. LiPo handling is critical. Store transport in a fireproof bag, never charge damaged or puffy cells, charge on a non-flammable surface and never unattended, use the manufacturer's charger. LiPo performance falls in cold weather and voltage drops during flight. Low battery warnings mean land immediately. Motors and ESCs. Brushless motors are efficient. After a crash check, motors spin freely. Gas engines exist for large drones but are less common for basic operations. Systems, the brains and nerves. Flight controller processes sensor data and stabilizes flight. GNSS GPS enables position hold and return to home, RTH. Set RTH altitude to clear obstacles and know how it behaves. Sensors, IMU measures acceleration, rotation and must be calibrated on a level surface. Compass gives heading and must be calibrated away from magnetic interference to prevent flyaways. Communications link, C2, is the radio between controller and drone. Watch for interference near metal structures or power substations. Payloads like cameras affect flight time and handling, ensure proper balance. Sample exam style questions. 1. What is the most important pre-flight check for your drone's batteries? A. Painting them a bright color. B. Ensuring they are fully charged and undamaged. C. Weighing them. D. Checking their manufacturing date. 2. What does the return to home, RTH safety feature do? A. Lands the drone immediately. B. Automatically returns the drone to its takeoff point. C. Flies the drone to the nearest airport. D. Takes a picture of its location. 3. Why should you calibrate the drone's compass before flight? A. To improve camera quality. B. To increase battery life. C. To ensure accurate navigation and prevent flyaways. D. It is required by law every single time. 4. What is a significant risk associated with lithium polymer, LiPo batteries? A. They are very heavy. B. They cannot be recycled. C. They can catch fire if damaged or improperly charged. D. They only work in warm weather. 5. A hexacopter has an advantage over a quadcopter because A. It is always cheaper. B. It can fly twice as high. C. It may be able to land safely if one motor fails. D. It does not require a pilot certificate. Absolutely. Human factors is a critical subject on the drone pilot exam. It moves beyond the machine and focuses on you, the pilot, your limitations, your decision-making, and how you interact with the technology. It's about understanding why humans make errors and how to prevent them. What are human factors? Definition: the study of how people interact with equipment, procedures, and their environment. It seeks to understand human strengths and limitations, physical and psychological, and then apply that knowledge to improve safety and performance. In aviation, it's often summarized as the dirty dozen, 12 common factors that lead to human error. While you don't need to memorize the full list, understanding these concepts is key. Key human factors concepts for drone pilots. Here are the most relevant factors with definitions and examples. 1. Stress. Definition: a state of mental or emotional strain that can result from demanding circumstances. Impact: hurries your decisions, narrows your attention, you might miss critical details like a low battery or an aircraft, and makes you prone to errors. Example: you're on a tight deadline to get a shot for a client. This stress might cause you to rush your pre-flight checklist or decide to fly in windier conditions than you should. 2. Fatigue. Definition: a state of feeling tired, weary, or sleepy resulting from lack of sleep, long work hours, or intense mental activity. Impact: severely impairs judgment, reaction time, and information processing. It's as dangerous as being impaired. Example: after a long day of work, you decide to go fly at sunset. You might misread your controller display or be slow to react to an approaching helicopter. 3. Complacency. Definition: a false sense of security that comes from being familiar with a task. You start to assume everything will be fine and stop paying close attention. Impact: you skip standard procedures. I've done this 100 times, I don't need to check the propellers today. This is a major cause of accidents for experienced pilots. Example: you launch from your usual field without checking for new NOTAMs, unaware that a new film production has set up a temporary helipad nearby. 4. Pressure. Definition: the feeling of being compelled to perform a task, often from an external source, a client, a boss, yourself. Impact leads to cutting corners and taking risks you otherwise wouldn't. Example: a client is on site and pressuring you to get the shot. You might be tempted to fly closer to people or in controlled airspace without permission to get the job done. 5. Lack of communication. Definition: a failure to effectively share or understand information. Impact: critical information is missed. This is crucial if you are flying with a visual observer, VO. Example: you and your VO don't establish clear signals for stop, land, or aircraft nearby. When a plane approaches, the VO's warning is unclear, and you don't land in time. 6. Lack of resources. Definition: not having the necessary tools, knowledge, or information to perform the task safely. Impact: forces you to improvise unsafely. Example: you arrive on site and realize you forgot your tablet for the controller. You decide to fly using only the small screen on the remote, making it harder to see your drone's orientation and battery level. 7. Lack of awareness, situational awareness. Definition: not knowing what is happening around you and how it affects your operation. This is the #1 skill for a pilot. Impact: you lose track of your drone's position, battery level, airspace, or other aircraft. You become reactive instead of proactive. Example: you are focused on framing the perfect camera shot and fail to notice your battery has dropped to 20% and the wind has picked up, making it difficult to return home. 8. Distraction. Definition: anything that draws your attention away from the primary task of safely piloting the aircraft. Impact: a momentary distraction can lead to a permanent loss. Example: you answer a phone call or look away to talk to a bystander. In those few seconds, your drone drifts into a tree or over a road, the I'm safe checklist, a pilot self-check. Before any flight, ask yourself: illness, am I feeling sick? Medication, am I on any medication that causes drowsiness or impairs judgment? Stress, am I unduly stressed or rushed? Alcohol, have I consumed alcohol or drugs? 8 hours from bottle to throttle is a standard rule. Fatigue, am I tired or well rested? Emotion, am I angry, upset, or distracted? If you answer yes to any of these, you are not fit to FL.